All right, good morning, everybody. So, we've made it to September. That's a start. My favorite time of the year is the fall. I like the, as I call them, the burr months. So it's starting to cool down a little bit, starting to feel a little more like fall. Still got a ways to go, but it'll get there. So last time we left, we started talking about this idea of metacognition. I believe we got through this slide, but I want to finish up the slides here and then talk to you a little bit about some of the readings that I had posted for today, as well as the talk to you a little bit about the learning strategies inventory. So the results are in on that, and so we'll talk a little bit about that as well. So. Last time we talked about the need to preview before you go to class, preparing for active reading. Paraphrasing your information is very, very important. All of these things are important for you to prepare yourself for class. Talked a little bit about active reading, reading for learning as opposed to reading for, it's not like reading Harry Potter or whatever, right? You're going to have to take your reading seriously. Using the textbook correctly. I think I gave you all the example of the student that came to my office and opened the book and it cracked because it had never been opened before. I know students complain about the cost of textbooks. Costs are an issue. Fortunately, Eagle Direct makes it a little more affordable for you if your materials are available on Eagle Direct. But make sure you use it. They do cost a significant amount of money, but the most important thing is if you don't use it and use it correctly, no matter what it costs, whether it was $20 or $200, it's going to be a waste of your money. So make sure you get the full use out of your textbook. And again, faculty assume you've read and looked at the material before you come to class. That's a big difference between college and high school, of course. Make sure you attend class and take notes by hand. We talked a little bit about there's something about writing out notes by hand that is different than typing or trying to just memorize, and so that's certainly a truth, I think. We talked about doing your homework without using examples. Make sure you keep on top of that when you're assigned. So in your Gen Chem class, after you've read and you've prepared and you're getting ready to start working homework problems, make sure you try it first on your own without looking at the examples in the book or the examples in your notes, because that's going to give you an idea as to how prepared you are to actually solve those types of problems. Okay? We talked a lot about teaching the material, right? It's important to be able to teach the material because unless you can teach it, you really don't understand it. We talked a little bit about that as well. Talked a little bit about working in groups, talked about the pros and cons of that, right? So the pros is that you're going to get a group of people together that are working on the same type of material. The con, of course, is that people tend to gravitate to each other who are in the same situation. So make sure your study groups are diverse in terms of what you all know well and what you don't know well so that you can help each other. But getting a group of folks together that are all struggling with the same material and not really understanding, nobody really understands it, is really not going to be that helpful to you. Creating your own exam or your own exam questions. That's a great way to prepare, right? So as you start thinking about the upcoming exams, start asking yourself what kind of questions would you ask if you were asked to create the exam. And then, of course, I put in number 11, personal reflection of your performance is very, very important metacognition piece. So we talked about all of these last time. I just wanted to reiterate them. And so now we'll continue on with the so-called study cycle out of Dr. McGuire's book. Now, the title of my presentation here is Stop Studying and Start Learning, so I'm going to call it the learning cycle, of course. But you need to, again, remember, preview before class. You have to prime your mind for what it is that the professor is going to be talking about. Just like if you're going to paint a wall, you prime it before you paint it. Yeah, you can slap paint on a wall, but it doesn't look good if you don't prime it right, okay? Same thing with the information that you're going to learn in any class. You need to be primed, ready for that information, and so previewing is very, very important. Attending class is extraordinarily important. Okay? It's different than high school, obviously, right? A lot of faculty don't take attendance, and so you might think, I can skip that class. But you need to think about it as getting what you pay for, in my opinion, okay? You spend a lot of money to be in each and every one of your classes. If you're not spending it out of your pocket, somebody is. Federal government, mom and dad, uncle, whoever. You may be working a job to help pay to be here at USM. And so you are paying money to be here, whether you're in class or not. And it turns out you're paying about 50 cents a minute, right? That's $30 an hour to be in your class. So keep that in mind. You are paying for this. So make sure you get your money's worth. After you attend class, it is very, very important that you review. All right, there were some things on the strategies inventory that we'll talk about today about reviewing material. This is very, very important, as close to after class as possible. Many of you have classes back to back. I know it's not going to be possible after you leave your general chemistry class to immediately review, but as quickly as you can after class. Why is this important? Pardon?
So you're not forgetting what you learned.
Okay, so you're not forgetting what you learned. What else? Why couldn't I just review maybe at the weekend? So I had a class on Monday, I'm done. I'll review that on Saturday.
Too much time has passed for your brain to like keep it in grasp.
Okay, yeah, so you start losing it, right, if you don't review it, right? Absolutely. What else? How good are our memories? Are they good? Now, human memory is actually quite bad. Even for those of you who have very good memories, really it's not that good. We fool ourselves all the time. We remember things that really never happened or happened differently, right? But the quicker that you can review after class, the more you're going to remember about what the instructor said, what the professor said about a particular topic. As you're going over your notes, you will, it'll still be fairly fresh. So if you're going over your notes, you're like, I don't remember him or her saying that, right? You can make a mark of it, and that's something that you can go talk to your instructor at their office hours for. Of course, after reviewing your class notes and all of the stuff from class, you're going to want to get into learning mode again, study, right? You're going to want to study the material. You're going to want to reread the material. You're going to want to go back through your notes a little bit more. You're going to want to do all of that stuff. And then this is where most people stop. I'm done. I've studied, right? Now you have to assess what you've done. What does it mean to assess what you've learned? How do we assess our learning? A test, right? Okay, so a test is an assessment. It's an assessment that I use for a class, right? Not in this class, but it is an assessment that you can use for a class. How are you going to assess yourself, though?
You can always go online, look up worksheets on whatever you're learning at the moment.
Yeah, you could go online. You could find worksheets. You can go into your textbook.
Write down everything you know or you didn't know and see how well you actually know it.
Okay, we're going to talk about a method that kind of uses that here in just a moment. Yeah, but that's one way, right? The easiest way for most of you in the sciences is each and every one of your books has, at the end of the chapter, problems to work. And your instructor may have assigned a certain number of those to you. At a minimum, you need to do those. And if you still find yourself wondering about how much you really know about that topic, you need to find additional problems. You can find them in the book. You can find them online. You can find them in any number of places. You can actually go to the library or to the tutorial center. We've got all kinds of books. You can find all kinds of problems to work there, okay? Many of these problems come with solution guides. What's the problem with a solution guide?
It sounds like somewhat like photo math.
Like what?
Photo math. You know how it shows you shows you how to work it?
Okay, yeah.
Without telling you the answer.
Yeah, that's what a solutions guide will do, right? You'll look up your problem in the solutions guide and you'll go, oh, that's how they solved it. Oh, that makes sense.
It's kind of a handicap.
It is a handicap. It is very much so a handicap in a way, right? It's a crutch. Now, what is it? How do you use it properly? You struggle through the problem, you get to where you think the solution is, and then you look up the answer. And if you don't get the right answer, don't look immediately at what the whole solution was. Try to go back and solve that problem again. And then if you struggle with that, then go back and look at the solution. But here's where students will frequently make a big mistake with that. They will look at the solutions manual and they'll go, okay, now I know how to do that problem. You need to go and find another problem that's similar but with a different answer. And you need to work at the test to make sure that you know that. Notice this is a cycle. After your assessment, if you go, oh, I missed 5 of the 20 questions that I did, you need to go back and restudy and do more learning about those areas that you struggled with, right? And so working problems is very, very important here. And again, this to me is the true learning cycle. This is what it takes to learn, okay? It is actually very difficult to truly know something. I want you all to know that. It is very, very difficult to truly know something. When you get to my stage in a career, you will actually start to think that you don't know anything about much. Right now, you all think you know a lot about a lot. And you do know a lot. But the more you learn, the more you realize how little you really understand about the world in which we live. But this learning cycle helps us figure all of this stuff out. And this is kind of like a research cycle as well. I want to talk about the Feynman technique. Does anybody in here know who Richard Feynman is? Probably shouldn't. He died a long time ago now. But he was a Nobel laureate. He was a physicist, a theoretical physicist. He worked on the Manhattan Project. How many people in here saw Oppenheimer? Okay, he worked with Oppenheimer at Los Alamos, okay, when he was younger. And he became a very famous teacher. Not only did he win a Nobel Prize, but he is probably considered in science to be the best teacher that you never had. That's kind of the joke that goes around. Okay? He was very famous for his lectures. He was very famous for interacting with students. He was very famous for being able to take what most people would consider a complex topic and break it down into understandable chunks so that the average individual could really understand it. He was a whiz at that kind of thing. Okay? And so he developed this technique, and this is how he learned. And if you go out on YouTube and you do a little research about him, watch some of his interviews, people always ask him after he won the Nobel Prize, you know, how does it feel to be a genius? And he said, I'm just an ordinary person. He always said, I was just an ordinary person that had an extraordinary curiosity about the world. And I pursued it and pursued it and pursued it and pursued it. I looked at the world from a different point of view, he always said. But he never considered himself a genius. And he actually said many, many times that he struggled with learning topics. And he came up with this way of doing this. And he said, the Feynman technique, this is it in a nutshell, okay? You really don't understand a topic if you can't explain it in simple terms to your grandmother, grandfather, or a young child. If you're using a lot of words to explain a topic, you probably really don't understand it. You're filling in things and putting in a lot of filler. You should be able to explain a topic in a few sentences, okay, for the most part. So there's a few steps to the Feynman technique, and you might find this technique helpful. Step 1 is you're going to get a piece of notebook paper. You can actually use an iPad, it's fine, or whatever you use these days. Okay, but you're going to have a page, and you're going to devote that page to that topic. You're going to write the title of the concept you wish to learn at the top of the page. And then, without a textbook or whatever, you're going to sit there and you're going to write down everything you know about that concept on that page. And if you find yourself going over to a second page, you probably haven't condensed your knowledge down enough. You haven't simplified things in good terms, okay? So you're going to write down everything that you know about it on that page. Step 2 is you're going to explain that concept to somebody. Again, this is kind of like teaching. That's that teaching piece, right? By teaching, we learn. And you're going to explain that concept to someone in simple terms. Can you just find somebody off the sidewalk and explain to them that topic that you learned in your chemistry class today? Right? Now, I'm not telling you to go out and actually grab somebody off the sidewalk and say, hey, let me explain to you, okay? But you should be able to do that, right? You should be able to explain it to them in simple terms. Somebody that didn't attend your lecture or whatever, you're going to work examples at this point, okay? Now, you all think a lot of your chemistry problems are math, right? They're really math problems, right? But they're not really math problems. Math is a language that we use to answer the problem. You should be able to answer everything in chemistry without solving a single solitary equation. Why is it that a gas expands when heated? I can calculate that, but I should be able to explain that in regular terms. Why is it that when hydrogen and oxygen react, they give water plus a lot of heat? Well, I can calculate all that out, but I should be able to explain that in simple terms, okay? Especially when you get to organic chemistry. When you get to organic chemistry, you're going to do very little math, but you're going to be using concepts to figure out how to take this set of stuff in bottles and making this set of stuff that you want, okay? And so there's a logic to it, right? So again, in simple terms, can you explain something to someone on the street? Very important. If you can't do that after you've done these first two steps, then you need to review your explanation and identify areas that you struggle to explain in these simple terms. This is self-reflection. Feynman didn't call it self-reflection, but that's really what it is in our learning strategies, right? So, after you've reflected on that, you're going to go back to the books, you're going to go back to your notes, you're going to go to your professor's office hours, whatever you have to do to try to learn as much additional about that and fill in the blanks as you can. And you're going to add the new things that you've learned in that process to your page. And again, keeping it simple and straightforward. And then step 4, identify areas where you used a lot of technical language. Think about these areas and try to simplify and use analogies. We explain the world in which we live by using analogies. Okay? We do comparisons of things. That's what science really is in a way. Right? We don't know anything for sure, but we know things relative to one another pretty well. Right? And so we can use analogies for these types of things. So again, getting down to that simple process. Here's a photograph of Dr. Feynman in the 80s. Many of you don't remember the space shuttles at all, let alone the fact none of you were born when the Space Shuttle Challenger exploded. But when the Space Shuttle Challenger exploded in 1980, I believe it was 1986, Feynman was put on the commission to try to figure out what happened. And he could have explained that to the commission in terms of tensile strength of materials and flexibility, yada, yada, yada. He could have done all kinds of technical explanations for why he believed the shuttle exploded. But instead, he goes into the commission meeting, he's got a glass of ice water, and he's got the O-ring. And he sticks that O-ring in the glass of water, and it freezes, and it gets hard, and it gets brittle, and it starts cracking. And the day that the shuttle exploded, it was an unusually cold day in Florida. And so he was able to explain that without solving a single solitary equation, without using any complicated technical language to the commission. That was his superpower. He was able to explain things down to that level that just about anybody could understand it. That's what you need to be able to do in any of the classes that you're in. Certainly your science classes, your math classes, your STEM type classes, okay? You're going to need to be able to explain these things in simple terms. So if you find yourself using a lot of technical language, if you find yourself teaching it to somebody and going, well, it's complicated. When you say, well, it's complicated, you really probably don't understand it. I find myself doing that a lot in my current job. When somebody comes to me and says something, I go, well, it's complicated. Then I stop myself and I think, maybe I really don't understand what I'm about to say. Right? So keep that in mind. This 4-step method works for more people than it doesn't work for, and I would highly recommend you give it a try. So here's what it might look like. Okay? None of you have had organic chemistry yet, so don't worry about the topic. But this is how I sat down and did the Feynman technique before I went in and gave a lecture on carbocation rearrangement when I was teaching organic chemistry. Okay? I literally did this before I went in to teach the subject. Even though I've got a PhD, I've done carbocation rearrangement chemistry my entire career, I wanted to make sure that I could explain it in the simplest possible terms to my students. Okay? And so you'll see I took a notebook page, I started writing down everything that I know. I actually used diagrams that helped me explain it. I used very simple terms like lazy, okay, energy, things that we really understood very easily. I didn't start talking about the mathematics of orbital configuration or anything like that, okay? So this really does work. It helps you truly understand what you're getting ready to talk about, okay? And then, of course, we've already talked a little bit about mindset. Mindset's very important, right? You can have a growth mindset, you can have a fixed mindset. But we're born with our mindset, right? We are not born with a mindset. We are born with many things. Mindset is not one of them. You develop a mindset over time. You develop a mindset based on who you interact with. Okay? You can choose to have a growth mindset. That's where you're going to be the most successful. Fixed mindset is where you basically kind of given up. Okay? Believe you're either good at it or you're not. Each and every one of you can be an excellent chemist, or an excellent biochemist. There's nothing magical about it. Okay? There's no such thing as magic, right? So make sure you stay in that growth mindset as best you can. I want to talk for a minute here about the learning strategies inventory. So you all took the learning strategies inventory last week. You turned that in. I scanned it. I don't know what your answers were. They were all anonymous to me that way. Okay? So it doesn't matter. But we're going to go through each and every one of these because your notebook reflection today that will be due on Friday is about taking each and every one of the learning strategies that you marked B on, which was no. How could you make that a yes? That's the assignment for this week, okay? But I want to kind of go over this and kind of give you the numbers from the class, okay? So first, I always preview the material that will be discussed before I go to class, right? So before you go to your general chemistry class, before you go to the math class, have you previewed the material that will be discussed before you go to class? 58% of you said you do that, okay? 58% of you said that you do that. That number needs to be 100% of you, okay? Again, if you don't prepare your brain or your mind for the information that you're about to receive, it won't stick. It just won't, okay? And again, one of the big differences between college and where even junior college or high school is that once a class is over, it's over. We're on to the next stuff, right? And that's the way our curricula are set up. But 58% of you agreed with that you did do that. And so the second one, I go over my lecture notes as soon as possible after the lecture and rework them and note problem areas. 37% of you said that you do that. Again, it's very, very important that as quickly as possible after lecture, you go through your notes and reorganize them. You know, you might be taking notes very, very quickly, right? But it takes time to rewrite, rework them, note some problem areas, things that you need to study on. Okay? 37% of you agreed that you did that. The third part of the inventory, I try to do my homework without using example problems as a guide or copying answers from my class notes or textbook. 79% of you agreed that you did that. Okay? So a little better. Most of you try to work your problems without using examples, and that's good. 4, I regularly go to office hours or tutoring to discuss problems or questions about the homework. Only 5% of you marked that you did this. Why is this one, and I'm asking you as a class, why is this one such a low, yes, I do that? Why don't you go and use your tutorial center hours or your office hours with your faculty member?
I got 2 reasons for, like, because one of them I personally have struggled with.
Mhm.
Another one is just other people have asked me. You don't know where it's at, and it's too far of a walk.
Too far of a walk and you don't know where it's at. Okay.
I'd just be busy, don't have time to go.
Being busy.
I work 2 jobs and I do a lot of my schoolwork at work.
Yep.
I use office hours, like, unless I really, really don't understand something in class and I can't figure it out,
Okay.
which doesn't always make any sense. I'm not saying I'm a smart person in the world, it's just,
No, no.
if I'm paying attention in class, I know how to use it, I don't need extra help outside of it.
Okay, that's fair.
I get really anxious around people.
Okay. Get anxious around people. We can be scary folks sometimes, can't we? Yeah.
A lot of office hours aren't at like convenient times of day for students.
They're not at convenient times? Okay.
A lot of times they're scheduled during other classes.
Scheduled during other classes. That's right. So I'm hearing all the typical things. Did you have a? No, okay, sorry. Any others? All right, let me address a few of the things. I understand where you're coming from on most of those things. When I was a college student, I worked a job, and I worked a work-study job. I actually had 2 jobs going to school. I was married at the time. I was a little bit of a non-traditional student, even though I was of traditional age. And the person standing in front of the class is a bit intimidating. We call them doctor, professor. They've got all this knowledge, at least we think they do, right? We tend to think, oh, if I'm going there, that's going to be me showing that I really don't know anything, or I'm not learning from this individual. Okay? A lot of those things, and I know it's easier said than done, but you really do have to kind of just put that out of your mind and go see your professor. They schedule these things at times that are convenient to them. There's no doubt about it. Okay? However, I don't know of any professor that won't take appointments as well. So if you're looking at my office hours and you go, well, he's only available Wednesdays from 3 to 5. I can't do that because I work. Send me an email. I'd like to come talk with you about X. Now, each and every one of you are going to have to come to my office and talk to me at some point this semester. That's part of what we're doing for our grade, right? And the reason I'm doing that is I want you to physically get up, walk to somebody's office, and be in an office hour for a minute or 2. I want you to have that experience. That is an experience that most of you have probably never had in high school, right? You went to your class, the teacher was there, they talked for 30 minutes, and then they gave you 30 minutes or 20 or 30 minutes to work on your stuff, and they walked around and helped you. It's different here, right? We expect you to do things outside of the class and come to us as there are issues. And is it inconvenient? Absolutely it's inconvenient. There's nobody would disagree that there's an inconvenience associated with it. But we need to get more of you into this, that you're not afraid to go see that instructor. They are not going to bite your head off. They are not going to call you stupid. They are not going to say, that's so easy, anybody should have been able to do it. Don't have those kinds of thoughts in your head. I would much rather help a student up front before it gets really bad than trying to help a student at the end of the semester. Do you know when most of my office hours are used? When I'm teaching my real class, my real organic class? 2 days before each exam and the day before the final. Now, the ones before the exam are usually maybe 10% of the class shows up. The rest of the time, nobody shows up. maybe 10% of the class shows up. Before the final, day or two before the final, maybe 50% of the class shows up. And what do you think people are wanting to know the day before the final? Do you think they're coming to me for help?
Can they get extra credit?
Can they get extra credit? They're asking for extra credit. No, we don't have extra credit. Right? What else are they seeking?
More time
Maybe more time?
for what will be everything.
Yeah, they're trying to get out of me what's actually going to be on the exam.
Is it multiple choice?
Is it multiple choice? They usually know that for me, right? I'm pretty open about that kind of stuff. I don't throw any wrenches in. I usually post my old exams so people can take a look at those. And I go through a lot of tissues those 2 days, unfortunately. And, you know, we could have prevented that if you'd have come and seen me the first week, second week, third week, fourth week, fifth week, as opposed to the 13th or 14th week. Okay, we could have worked those problems out. It's very difficult for me to work a miracle 2 days before the final exam. In fact, it's impossible. There is no such thing as me being able to work a miracle. Okay? I can help you out along the way if we start early. I can't help you out too easily if it's 2 days before the final exam. Okay? I rework all of the homework problems and questions before the test or quiz. 74% of you said you did this. Okay? That's a good thing. The problem with this is that many of you do this too soon before or too close to the exam time. I call it cramming for the exam. Right? So if by before you mean the night before, while it might help you a little bit, it's not going to be as useful as if you are truly doing it before and as assigned before the next test or quiz. Okay? I spend some time studying for this class at least 5 days per week outside of class. Okay? 21%. Now, what I'm hoping here is that some of you were just applying that to Chem 108. Chem 108 is not about a normal class, right? We're not studying, we don't have tests, we don't have all of that kind of stuff. We don't talk about any serious chemistry concepts. That's all what you're learning in Gen Chem, and you'll learn in organic and all those other things, right? You've got to spend some time every day in your classes. I don't care whether it's your English class, your history class, your chemistry class, or your math class. If you're on a Monday, Wednesday, Tuesday, Thursday, or a Monday, Wednesday, Friday schedule, whatever your class schedule is, if you're not interacting with the material at least 5 days a week, you're going to struggle a little bit. Okay? The seventh, I make mnemonics for myself to help remember facts and questions. 61% of you said that. What might be a mnemonic that you would use in chemistry?
Oil rig.
Oil rig. Oxidation is loss, reduction is gain. Okay? So when you're talking about oxidation and reduction of an element, okay, that's something that, that's the one I actually use. I'm from Oklahoma, which is an oil state, so I use oil rig. Some of you might have used Leo, the line goes Gur. Loss equals oxidation. Gain equals reduction. Leo and Gur. Okay? But there's all kinds of things that you can do to help remember the facts and equations. Okay? Q equal MC delta T. That's an equation that you're going to learn in lab maybe next semester in 107. Okay? That's easy for a lot of people to remember because they always go, well, Q equals MCAT. And many of you who want to go to medical school know what MCAT is. Right? That's the exam you're going to have to take. Right? And so you can make these types of little mnemonics and little sayings to help you remember these types of things. I make diagrams or draw mental pictures of the concepts discussed in class. Nearly 80% of you said you do that. That's good, okay? Mental pictures and diagrams are going to be very, very important, okay? An equation, right, is just an equation. But that equation can actually usually be plotted out in 2 dimensions for chemistry, right? We have something on the x-axis and the y-axis. We can see how things go. It allows us to see the trends, right? For those of you who like to follow the stock market, you like to see this kind of stuff all the time. It's how is the market doing today? It's a graph. Okay? We understand these types of things. If it's going up, hey, probably if I put a little bit of money in, I'm going to make something. If it's going down, I'm probably going to lose something. Right? But dealing with those types of mental pictures and concepts and diagrams is going to be very important for you. So I'm glad to see so many of you using that. Okay? Participation in study groups, where you do homework and quiz yourself on the material. Only 18%. Okay? I know it is very difficult to make friends sometimes. It is difficult to, many of us are shy. But again, this is very important because you're going to be working with people that might know something that you don't, right? And so this is very, very important concept to work on. Reworking all of the quiz and test items I've missed before the next class session. Notice before is in a little different font there. Okay. You will get a test. You will not perform as well as you think you should have. You will get angry, you will wad it up, and you'll want to throw it in the trash can and forget about it. Don't do that. Take it back, rework those exams before the next class. So if your general chemistry instructor gives you back an exam today, and you've got the next class on Friday, rework those before you get to the next class. That's a good opportunity to ask the teacher some things about the exam before it gets too cold. But 58% of you said that you do that. And then 11, I realize that I can still do well in the class even if I've done poorly on a quiz or test up to the point. And nearly unanimous, 92% of you said that you realize that. Okay? It is very, very important to keep in context each of your assignments, what kind of percentage they contribute to the overall. Okay? So, why does it matter that I've given all of this statistics kind of stuff? Well, it matters because we know from research, not research that I've done, but research that Dr. McGuire has done, we know that out of those 11 things, if you do 9 or more of those, chances are you're going to get an A in that class. We know that. If you do 9 or more of those, that means you don't have to do everything, right? But if you do the vast majority of those things, okay, you're likely to get an A in the class. If you really put in that kind of effort, you're probably going to get an A in your class. If you do 6 to 8 of those, you're likely to get a B in the class. If you do 4 to 5, you're likely to get a C. If you do 2 to 3, probably going to do somewhere around a D. And most people who fail do 2 or do fewer than 2 of those things on that list. Okay? This was studied over and over again at LSU in big class sections. She had a lot of data to work with. She ran the Learning Center. She was a chemist, but she ran the Learning Center. That was what she did. They had huge classes of students that would come and see her. And over the years, she found that the student that came to her that was struggling at the beginning of the semester and worked with her and implemented 9 or more of those responses ended up getting an A. So, most of us think that being successful in a class, a C is successful for sure, but everybody typically wants to do better than that. So most people will settle for an A or a B. So if you can do 6 or more of those 11 things, you're likely to be in the B or better range. Okay? That's why it's going to be important for you to look at your inventory and the things that you said no to. Today in your self-reflection in your notebook, you're going to try to tell me how you're going to turn those around and make them true responses. Okay? Anybody have any questions about that? All right. So let's get into Canvas. And I had posted this piece. So Chemical and Engineering News talks with Julie Dunn. Okay, a biomolecular archaeologist. Why would I put something in there for you to read about a biomolecular archaeologist? That doesn't sound like chemistry at all, does it? Archaeology? Bio? Right? So why did I pick this for you all? Why did I feel like this was important for you to read?
To show like the scope of biochemistry.
Okay. The scope of biochemistry, it's not all just about test tubes and E. coli cells and all that kind of stuff, right? What else? Would you all consider this a traditional path for this individual? No. What was special about Dr. Dunn? What was kind of unique? Was this her first career? She was an accountant to start out with, right? I mean, she dealt with spreadsheets and people's taxes and all kinds of stuff, right? But then got interested in doing something else, went back and got a PhD. That is not usual, right? I did the usual thing. I started off in college, I got my bachelor's degree, went and got my graduate degree, did my postdoc, became a professor. That's the traditional route. It's the boring route. Right? This person started off probably young going, I want a job that pays a lot of money. Accountants make a lot of money. I'll become an accountant. Started working with that for years. Probably found that she got bored doing that kind of stuff. Just really wasn't her thing, although she was probably decent at it, right? Then she decided to go back and get a PhD. Anybody remember what she got a PhD in? It was a chemistry-related PhD degree. Yeah, it wasn't a bio. But it was actually geochemistry. So again, kind of chemistry of the earth, and now she's a molecular or biomolecular archaeologist. What does she study? What does she look at? Huh?
Lipids and like old pots, like ancient pots.
Yeah, so she looks at these ancient pieces of pottery that they used to use for like baby bottles. I had no idea that they actually used pots for baby bottles back in the day. And she looked at lipids. Anybody know what a lipid is?
A fat.
It's a fat. That's right. So she's looking at these so-called fatty acids that have gotten stuck inside the clay of these old pots, and I'm sure she probably deals with these broken pieces that are collected at a site. And why is this important?
To know what they ate and fed their children and things like that.
That's right. Yeah, so she's studying, what was it that mothers fed their children back, 1,000, 2,000, 3,000 years ago. It's really amazing if you think about it, that these little molecules of fat are remaining in these pots, and thousands of years later we're able to actually get those out and study them and know what food source that came from. Was that dairy? Was it mother's milk? Was it, we can figure that out by looking at the different fats. That's pretty interesting. Okay? And so this is I would say, a non-traditional type of career. But again, the power of chemistry, biomolecular techniques, however you want to think about it, coming into play into studying these areas of archaeology. Okay? So again, I want to show that if you're going to be a chemist, you can have a wide array of interests that you can pursue with that degree. Okay? So many of you may find this interesting. Some of you may find this particular piece boring, but nonetheless, it's an example of where somebody has pursued kind of what we would call the non-traditional track. All right, this one was a bit long. This was actually a verbatim transcript that got published for Jeffrey Kovac. Jeffrey Kovac wrote a book many years ago called The Ethical Chemist. Got interested in ethics in chemistry. Why is it important for me to talk to you a little bit about ethics?
Because of the career choices we're choosing.
Pardon?
Because of the career choices we're choosing. Or something.
Okay. What else?
Sometimes you'll deal with people and you have to know how to treat them.
Okay.
experiments to know what is ethical or finding a good balance. Because, you know, you can do these experiments on living animals, you do these things that some people may say is not ethical, and some people say is completely fine, so you have to find the middle ground.
Yeah.
Kind of the same thing, you have like a responsibility, I guess, as a teacher to make sure that you know right from wrong in case we're in a position where we
Ah,
make decisions like that.
that's right. I am no ethicist by training, right? But I belong to a professional society that has a code of conduct. I belong to a profession that grapples with these types of issues. I'm an organic chemist. Everything that I deal with is dead. I don't have to worry. I don't work with human subjects in terms of my research, but I do work with humans all the time, right? And how I treat my graduate students, how I treat my undergraduate students, how I treat my colleagues, all of these things are part of what the profession expects of me, okay? And what I should expect of myself, okay? So, I think it's very important that you all have at least a fundamental understanding of ethics and science. Many of you said some of the things that I like to hear. Biochemistry, it's going to be a little more of an issue for you than if you're an organic chemist or an inorganic chemist, or an analytical chemist, for example. In biochemistry, you might be doing experiments on animals. Some of you might think that that's okay. Some of you might think that that's terrible. Okay? But we have a code of conduct. We have a code of ethics because we also know that we can't just be doing experiments for just to torture animals, right? That would be wrong no matter who you are or what side you are on. I think we can all agree that just doing something to cause pain and suffering is not right, okay? And so we have these ethical things that we have to think about all the time. And in fact, we have boards set up at this institution to make sure that the research that is conducted. We have a board called IACUC. So if you're going to do any kind of experiment with a living animal, like a fish or a rodent or a monkey or whatever the case may be, you have to run those protocols through the IACUC board first before you do any experiment. We also have what's called an IRB board. If you're going to do research that involves a living human subject, that must go through the IRB board. That could be, I'm going to do a survey, or hey, I'm going to inject people with a particular medicine and we're going to see what happens. All of that type of stuff would have to go through our IRB board before we can do it. And again, it's to make sure that we are doing our research in an ethical manner. Okay? So he gives a lot of stuff about where he's at in terms of his current position in Tennessee, the fact that he's part of an honors program. He does mention that there are 4 characteristics of an ethical chemist, and he lists those there. Right? So the first characteristic being an understanding the ideals and standards that govern professional moral decisions. This is different than what we all know is right and wrong, right? We know that it is wrong to kill and murder. That's a societal thing, right? What we're talking about here is within our profession. Each and every one of you, being a declared biochemistry major, have already declared that as a profession for you, and you are bound to certain professional decisions, moral, ethical kind of things to think about. The second one being an understand the moral complexity of real-world situations. Real-world situations are always muddied by the human interaction. Okay? Anytime 2 people get together, even in science, where most people think we're wearing white lab coats and we're only concerned about the facts, right? That's an ideal, but that's not the reality. We have two people working on a project. There's always going to be possibilities for these real-world situations that can become complex. And they become complex because we all come with our own stuff. Some of us have certain religious beliefs. Some of us have certain cultural beliefs. Some of us have certain political bends, right? And anytime you get people that have those differences, you're going to have real-world situations that have to be navigated, okay? So these moral issues can certainly pop up. So he talks a lot about that. And then he talks a little bit about the gift economy. Does anybody know what the gift economy was?
Giving without the expectation of receiving something back.
Okay, yeah. So we all live in what most people think of as the economy, dollars, exchanging for things, for goods and services, right? I go to the gas station, I buy 10 gallons of gas and a candy bar, I exchange, that's that kind of economy, right? It's an exchange, there's an expectation of a payment in return for a good or service. But in science, we really live an awful, although there's the potential for that, and certainly many of us I make a living doing science, right? That's part of the real economy. But there are things that I'm going to leave behind that would be considered the gift economy. That's my research. That's my training of you all, right? Yes, I'm getting paid to be here, but I hope I leave a gift with you all in terms of when you go into your next classes and things, right? So we do have a foot in both of these worlds, so to speak. Okay. Scientific research can largely be broken up into these quadrants. On the top axis, you're looking, is there a consideration of use of what you're doing? And on the vertical, it's, are you looking for a fundamental understanding? If the answer to those is yes and no, right, you're talking about pure fundamental research, knowing for knowing's sake, right? Many of us do that kind of stuff. You can also say, yeah, I'm interested in the fundamental understanding, but I want it for a specific use too, right? That's use-inspired basic research. That's what Pasteur did, okay? And then you've got Edison down here in what's called pure applied research. Doesn't really care to understand the fundamental understanding of the world, but is considered with the use. That's kind of what Edison did. Okay, Edison, you all know, invented the light bulb. What else did he do? Invented some batteries. Right? The company General Electric was started by Thomas Edison many years ago. So that pure applied research, I really don't care to understand how it works. I want to find something that solves this problem. Okay? I would place a lot of engineering in that area. It's not a bad thing. Okay? I want you all to understand that. There's nothing bad about any of these things. Okay? It's just about the consideration of use and whether or not you're trying to have a quest for fundamental understanding. But these are going to bring in additional moral questions for many of you as well. Okay. So, he gives these 8 factors. I'm not going to go through all 8. We don't have time today. But he started talking about the ethics of choosing a research project. Each and every one of you, if you stick with this major, are going to have to do research at some point. You're going to go around and you're going to try to find a professor who's going to be willing to bring into the lab for at least a semester to do a research project. You're going to be faced with these things. You should find something that interests you. You should find something that you find valuable, right? You should find something that you find meaningful, okay? So choosing a research project is going to start you off there, okay? And there are many things that dictate what research projects get done. Money being one of them. Scientists are always faced with that ethical dilemma. Many of you might know about the big tobacco settlements that happened in the 90s, or at least have read about them, right? The tobacco industry was funding basic research, and since they were the funder, they also said, you can't publish that. We don't believe cigarettes cause cancer. You just found something that suggests it does. You're not going to publish that because we funded your work. That's an ethical issue that one has to be confronted with. Discarding data points. You're going to experience this in lab probably right now. Should I discard that data point? Maybe, right? There's ways in which we can legitimately discard data points, but we've got to be careful because, all of those data points don't support my hypothesis. These do, so I'm going to go with these. That's wrong, right? Can't be doing stuff like Writing a scientific article or report. It is a myth that there is no passion in what we write about in science. There's lots of passion about what we invest our heart and soul into these projects. And so it is a persuasive writing example, but we have to be careful there because we can go too far. Okay? And then conflict of interest and conflict of commitment. I think that's an important thing for you all to read about. And we're kind of out of time, so we'll stop there. So I am not going to be in class next week. I've got to go to a conference, but I am going to have a guest speaker here next week to talk to you. I'm trying to get the career services folks over, but I'll let you know more about that as time goes on. That's who I'm trying to get over here to talk to you. So for today's attendance, get out a piece of paper, put your name on it, and your ID number. Please print so that I can read it. And just leave it up here on your way out. And I will see you all in a couple of weeks.